Well, welcome to the CERIAS seminar for January 18th. Today, we're honored to bring back one of our alumni. Dr. Mamorthy Murugesan was a student with CERIAS in the computer science department, getting his PhD. Oh, I'm back. It's been over a decade now.
Yes, yeah.
And we'll leave it at that. And did work in data security, particularly looking at security in information retrieval. How can we protect ourselves when we search from revealing too much? But also looked at several other security issues. Then went on to work at Teradata for a number of years, where he help them expand from Terra to Exa and larger, and doing query performance and related issues. But has now gone through, worked through a number of smaller companies. Most recently, he's with Normalize, and will be talking to us today about a number of data security issues, but particularly in the context of some of the kind of the latest and greatest data management architectures. So I'll turn it over to Mamorthy.
Okay, thank you, Professor Clifton. And actually, it's great to be here. I did this talk about in 2009, so about 13 years ago. Today, I'm going to talk about data security posture management, and in my company, we have been really focused on this area. It's a new emerging area. So my purpose of the talk is just to explain what it is about and why we need it, and also go through DSPM, so data security posture management, DSPM solution in detail. What are the components that we need to build to make this work, and share some of the challenges we have run into. And I'm hoping some of you will take up, and maybe some of the challenges will interest you to look further. And finally, end with conclusion, sharing some final thoughts. So this is very common knowledge, right? Public cloud adoption has been increasing steadily over the years. If you just go back 6 years ago, the spending is almost 3 times than what we saw, in 2016, 2017 timeframe. And why this is happening is, if you look at the other spectrum, this is really helping us fuel a lot of innovation and creating more and more areas for companies to come up and contribute, right? So previously, if you want to start doing something, you need to get a, you need to have your own data center. You need to plan for capex, and you need to have a lot of investments. Right now, that's not the case. So there are many companies relying on public cloud, and they are innovating, and which is great to see. And you can also see the provider side. There are many companies which are offering all these services in cloud. AWS, GCP, and Azure, they are innovating and making all these services which can help you build a lot of these innovative businesses. And so a great setup. But the key question is, do they have the same, when you do this, do you have the same security that we get in on-premise infrastructure? If you look at this and try to answer the question, maybe let's go through this, right? So this is one of the typical cloud deployment. This is taken from AWS website. As you can see, they have something called virtual private cloud, and many components are inside the virtual private cloud. So, for example, in the last section, you can see databases and many compute elements like EC2, Lambdas, and that help you run a lot of heavy workloads, and protected by configurations using security groups. And also you can do some sort of peering to allow only certain access that you want to give. But many services also outside, global services, for example, S3 and ECR. There are many services which are outside, but all of this are helping businesses to provide a very holistic solution to whatever they are doing, right? Innovation, and that's what is happening now. Now, to simplify this setup for let's assume a simple company, and they are doing this deployment. And typically, you will have the virtual private cloud that is protecting their infrastructure from internet. right? And if you kind of peek inside this deployment, you will see a bunch of compute elements. And you just imagine these are EC2 instances, virtual machines that you're launching to do a lot of compute. And on the other hand, you will also have data to support data storing. You will have a bunch of data related services. It could be S3 bucket, GCP bucket, and Azure blob containers, and so on, right? Many of them options exist, and this could be even databases, right? Previously, we used to host all this in data centers, but now you can host them in public clouds. There are like many, like MySQL, Postgres, and like a lot of support for even unstructured data stores and so on. But on the other, you also have users and roles where you can control who gets to access what. And this is the kind of the third dimension. Access policies are a critical part of how you want to control who gets to access what. And finally, if you look at this, the locking here is to make sure that you don't have any unauthorized access from outside of your own network, right? You're basically imitating a data center in this setup. In our example, let's assume that one data set here contains sensitive data. So what I mean by sensitive data, it could be a PII, personally identifiable data, or healthcare data, or finance data, whatever that is important for the business. If you go to the next slide, the previous slide I showed you, this is not a typical deployment for business to work, right? It's typically, you will have the business need will allow the companies to expose certain components to outside world. For example, you could be running servers, web servers that, of course, from the internet you can connect, provide proper authentication, then you can make use of them. And also data, many times you may expose certain data to outside to either upload, download, and share, and so on, right? There are many controls you will have for data. And users and roles, there's a concept of service accounts where from externally, you can create a service account to do certain operations. Many companies allow this to happen because many SaaS products rely on this to do certain things. For example, there are products where a service account help you control the cost. So this external access is absolutely not absolutely required for many, if you want to build a really successful business. But then when you open up this lock, the key question is like, how are you ensuring that you have your sensitive data that you have put in cloud is safe and secure? That's the question we are trying to answer. So hypothetically, let's look at a few ways in which this can go wrong, right? So you exposed certain times, misconfiguration is one of the key things that is normal and can happen. And for example, in this case, you're not supposed to make this available to public. And if there's a misconfiguration that allows access of a sensitive data to public, then you are basically exposing a sensitive data to outside. In the second example, you only exposed a compute to outside the world, outside your network, but exploitation, like using some vulnerability in the compute, EC2 or VM, the hacker can get to your sensitive data through one hop. That's in third scenario, you have allowed excessive privilege for one of the service accounts that you wanted to give. In terms of AWS policy configurations, if you just misplace one of the stars, and this can happen, right? Again, a misconfiguration, not intentional, but this can happen. Now, coming back to the cloud, I just talked about a very simple setup, but the setup in a real cloud environment is not as simple, right? I just showed you the first. It can just really explode. You can always start small, but you will see the explosion. In business cases, there's a lot of AI and ML use cases, and the need for accessing and analyzing a lot of data keeps increasing day by day, right? And as you hire more team members, they need to access, they need to store, analyze, and so on. That also increases a lot of in the data, and it keeps growing. Now, the key question is, like, when you are in this situation, when you opened up your cloud and when you're creating this infrastructure in a public cloud, how do you ensure that you have a clear understanding of your data security? And that's where we look at some of the key challenges that remains in this public cloud when you really put your sensitive data out there. First of all, the key you have wide variety of data stores. So, AWS, GCP, and Azure, if you look at all this, like many companies are hybrid, which means there is a huge variety and all of them will require different configurations. If you want to protect a public access for S3, it'll vary from a different provider, right? It'll vary and you need to be really knowing what you're doing, and this can lead to misconfigurations. One of the examples I showed you, the multi-hop analysis, where you can protect one, but if you have one entity in the middle which has a weakness, and hacker can expose that. And how do you understand this? Because the cloud is so connected. I'll show you a graph later on. The links can go, like there could be many hops, and that can lead to a you can easily compromise one of the single user and get to the sensitive data. The example is, for example, the compromising a single user, the credential, they haven't changed the password for a long time, and somebody is able to crack the password and get access to them. And the access path analysis we talked about, going to multi-hops is a harder problem, and many times if you don't solve it, this can lead to again data breach, right? Understanding IAM is harder, so that's why the whole thing and how you approach this problem is even much harder. So data security posture. So having, just looking at this problem, data security posture management overall collectively tries to address this holistically. If you look at these are the questions, like where do we keep our data stores, and what do they contain, and who has access to them, and what are my risks? If you answer all these questions cleanly, you are in a better place, and that's what this data security posture management tries to provide. And so if you look at the solution, let's now dive into the solution. If you want to build a solution for this particular problem, you will need all of these components, and I will go through them in detail. But if you just look at your left, you have multiple cloud providers like AWS, GCP, and Azure. And we want to first understand where are my data stores, right? What do I have, and where are they located? Because in AWS, you can host data stores in different regions, different continents, and understanding that is the first critical piece. Second thing is to know where is my, what do they have, right? You could have 1,000 data stores, but you may not have anything sensitive. But you could have, like 10 of them, but you could just have many sensitive data inside, right? So you need to really understand what do they have. That's data detection or analysis. The second thing is, third is more about analyzing and understanding who has access to it. We looked at an example where user has access to it, or EC2 instance access to it. Then these are the points, critical points where that can be, compromised to get access to your data. And this is really need to know that to be able to answer the security posture management questions. And finally, once you build this information, in our example, I'll go through, we are using graph. You can really understand what risks are there by writing a risk engine, and talk about it, how it's done, and also prioritization. This is very important to know because cloud it can be huge. It can lead to a lot of risks, and you need to be able to better manage them, and that's where the prioritization comes in. And we'll touch upon that. Okay, so I'll talk about all of this. And first is data discovery. So discovery is about understanding what assets you have where. And each of the cloud providers have really good APIs. For example, AWS has Boto SDK, Google has APIs, Azure APIs, and so on. So using this, we can actually get metadata about all the available data stores that you are deployed, right? In what region, what's the size, and so on. The first is thinking about the data model. And in our data model, each node represents a resource. For example, if you have S3 bucket, that becomes one node. And EC2 instance, the compute element becomes another node, and so on. And each of the nodes, the properties which we actually get from these APIs are actually stored in each node. For example, if you have a VM, you have to know what type. If you have a data store, you need to know what the volume of the data store. And if you're running image, you need to know what application is running and so on, right? All this metadata is part of an individual node in the graph. And the third element is a relationship. So you have all these nodes now, which we can populate using some of these APIs, and relationships are critical to know to connect them. For example, has role. A user may be given an admin role or just read-only role, right? These are completely different things, and you should be able to connect user node to a role which is different, and then the relationship will become has role, right? You can name these relationships, and many times you can also give user or a compute element to read a data or write a data, and all of the relationships will dictate how they are interconnected with each other. And this is very important as a very first part of the DSPM solution when you build it. And let's go back to our example. Let's say you have compute, data, and user and roles and access policies. And here, on the right side, I have two users, U1 and U2, and two data stores, D1 and D2, C2 and C1 are the compute elements, right? Now, what I'm representing here, U1 can read D1, and U1, the user one can also access compute element C1. And similarly, U2 can read D1 and it cannot read D2. It can only access C2, compute, right? And then but what you notice here is that C2 can read D2. So that's the permission we have given, but indirectly, U2 can also read D2 because of this permission. This is what the power of the graph that we can make use of when you build a data model like this. And this is actually a one smaller cloud account that we have, got all the metadata and showing as a graph. You can see this is from 200 nodes, 1K relationships, and how it's very nicely plotted and in terms of relationships and so on. And I have seen in an infrastructure where this number of nodes could be like 100, more than 10,000, and even relationships crossing 50,000 easily. But the power of how the data model helps us to see all these links and how they're traversing between each other. And this is what helps us to kind of look at the next stage. Second piece of the puzzle is data access analysis. So when I talked about nodes and properties, they are very easy to get, right? You can just query APIs and get them. But there's a one key piece in almost across all the cloud providers is that identity and access management. This is where you are defining what roles your compute or users can take, and what are the policies that control that give access to what they can do with that. In this case, so this is the AWS policy. There are, again, I just chose AWS as an example. This very similar things are applicable to different cloud providers. So here, this policy statement says that whoever has this role can access, can do all of these actions. So in this case, we're doing anything related to object access. But please note that here, if it is get object, it's a read access. And if it is a put object, it's a write access, right? That's a differentiation coming from depending on what the policy allows it. So it's this DSPM solution should really analyze all these privacy policies and build out relationships in the graph that helps us to do this further. And IAM is not only limited to users. We also notice, resources have different access policies, and that will control what we have. Let's say this policy has, all of these read access, right? So basically, this is preventing any write access, only read access. But if the policies like this allow to run any VMs, EC2 is basically VM, whoever has this role will have write access, right? The policy allows them to have the write access. So as part of the access analysis, very important to build and analyze the policies to create appropriate relationships that will help us to do the next stage of risk analysis. And we use multiple tools to do this, but this is the kind of the core problem, right? Just to be able to analyze the policies and to detect the appropriate relationships. The next stage is the kind of third is the data classification. I think one of the things we talked about is I want to know I want to know the data stores and where they are. And second thing is about what are they, who has access to them. Second, the classification, analysis helps us there. Third is about what do they have. Many times we can, as part of discovery, I've seen 500 to multiple thousands of data stores. To really manage the cloud environment in such a large scale, you have to really know what do they contain. And typically the volume of, if you just add up everything, terabytes and petabytes of data. So the classification is very important in an installation where people copy things, right? Like you have one data set and it's copied multiple times and ends up somewhere. And mission generated data sets are often we see, and development environments is often the case where production data is copied into a development environment and so on, right? It's copied multiple times over and over and so on. So it just leads to explosion of large number of data stores that we see and in an installation. So going back to the question of what is more critical, and this is where classification helps us to know by tagging what it contains, and that's the key piece that we want to solve by classification. There are multiple approaches to classification. There are like entity-based matching. This is purely matching in terms of like pattern matching, right? We know how the credit card number looks like. We know how SSN looks like. We know cell phone and so on. So there are many tools out there that can get us this information. And there is also exact matching. Many times companies have certain sensitive documents. They want to make sure that this doesn't end up somewhere else, right? Which is not secured enough. And that's where exact matching comes in very handy. And context-based matching, this is a kind of a futuristic types of use cases where we know certain groups of users are always creating sensitive data and certain group of users are always not creating sensitive data. If you have some context around that, you can really know what data stores will have sensitive data or not. And this is kind of the third type. So we make use of most of it and try to build a relationship. But now let's come back to our previous graph that we were kind of slowly building through this presentation. So if you just focus on the middle, U1, U2 users, and D1, D2 are data stores, and C1, C2 are compute. Through access analysis, we already built this. Now classification says, okay, D1 is a data store. It has finance data and also healthcare data. Right? So these two relationships are added as part of the classification. On the D2 side, let's say as part of the classification, we find that this has a PI data and also PHI data. So, in many cases, you might find many data stores not having this also, right? That's where the lack of the relationship. But this is good to know because now we can apply different type of risk and protection queries, and that's what we'll get next. So we built our graph with all this, really good metadata, enriched data with access and also what they contain, right? Sensitive information is present or not. The key question now is like, what is the risk of my whole environment when I have this deployed? Risk, if you look at the risk, it could be multiple categories: exposure risk, vulnerability risk, and data risk. And if you really focus on data risk, really we need to know what is the likelihood of exposure of my data containing sensitive information, right? I really care about certain things, PHI, PI, but if a data store doesn't contain some of this, maybe we don't have to really prioritize those. So with this, currently our graph has all of this, all the information that's necessary to identify this, right? We know all the data stores, we're not missing any. That's a discovery part. And who have access to it, all the relationship from user to compute, we have it, and what type of data is there. So if you go to the question, let's say we want to identify all the data stores containing sensitive data accessed by compute, which is exposed to internet. This is one of the first use cases we talked about. When an EC2 instance is exposed to internet, you can compromise it and get access to it. And let's look at the graph again. So if a risk is finding all the data stores, the first case we talked about, let's say C2 as a compute element is exposed to internet, and that path is here, right? From C2 to D2, this is a direct path. If our question is more like identify all the PHIs, healthcare data, accessible users, and who haven't rotated their password for more than 90 days. This is again, different types of risk, but you can see now U1 has direct access. If the U1 hasn't, the property says they haven't changed their password for 90 days, you can flag it. And also, the power of the graph, you can do one hop, right? For example, U2, user 2 has access to compute, and the compute can access a D2 containing PHI. So this particular path is we were able to detect because we have laid out everything like this, and helps us to detect very complex risk. This is just an example to show how we can detect it, but like we have identified like multiple hops where we can narrow down to exact risk and how it can happen and so on. Here we look at again going back to real environment. This is one of the environments where we have created all these links. Now this is an internet user, and from that I talked about a use case where we're talking about can access a compute element. In this case, it's a EC2 instance running in one of the VPCs, but it's exposed to internet. But this particular EC2 has a role that can give unlimited access to all the S3 buckets. See how exposing this, some vulnerability in this particular EC2 instance can easily lead to accessing all the sensitive data in a cloud deployment model. And this is what the risk engine can detect. And there are many ways we can write this patterns and detect them and expose to the customers. Okay, kind of the final piece of the puzzle is, I looked at the previous talk. It talks about security fatigue, which can happen. I talked about like 50 like 10,000 nodes or 15,000 nodes deployment. You can really have many risks, like sometimes even thousands, multiple thousands of risk. How do you really get to know which one is more critical to look at? And that's where the prioritization comes in. One of the model we have really used a lot is this metrics about likelihood and impact. So if you actually look at a particular risk, there are two aspects to this, right? One is this, how likely this can happen. And the other aspect is, if it happened, what's the impact? And many times, if you look at this, the leftmost corner, this is where likelihood of this particular risk is very unlikely, right? It's very low. And also, if it happens, this doesn't lead to a lot of impact, because maybe the data store, which is at risk, is not, doesn't contain anything sensitive. So it all, it belongs in this category. But let's look at the rightmost, right? It's this is where, let's say you have a compute which is running, which has a lot of vulnerabilities in terms of whatever the application is running, and which means that if it is high critical vulnerability, very easy to expose or compromise that compute. But in such cases, let's say that particular compute has access to a data store that contains very sensitive information, PA or PHI, very sensitive for your business, then it will belong in this category. So this particular prioritization allows us to really know which ones are critical to look at first. Typically, we need to start here, right? Because they're utmost critical, and you are at the risk of exposing critical data from your deployment, and that's what you need to look at. And this model really works well when you expose a risk to the users, and they can really take action. Okay, so having touched all the components, I want to kind of jump into challenges. So when we built this, we ran into multiple things, and some of these are even now applicable. So first is ETL, and if you think about the cloud deployment, which is external, and we are running all these APIs to get the metadata and update our graph. Typically the lag is what is important here, right? Like you can really do it a batch update, but many times a lot of critical activities can happen very quickly. And for example, you can change the misconfiguration can exist for 10 minutes, and then it may be fixed. But there was a brief period in which the risk existed. And how do you manage this? Because you cannot do batch, and how do you do it in real time? That is really one of the open questions things that continue to look at. Second thing is graph. And when you started using graph, it aligns really well with what all the things, all the things we wanted to do. But graph is not the only solution, right? There could be different ways you can data model this. There's a way you can keep some things in the graph, something outside, and do a hybrid approach. There are a lot of ways in which this whole DSPM solution can be made even more efficient. So that's where the data modeling comes in. Risk evaluation. One of the things I talked about is really knowing what patterns to look for. The finding this automatically using anomalies and just detecting those is probably another area that we haven't really explored a lot. But there we know there's plenty of work to be done there. Data movement. This is a very unique property in the cloud that we continue to observe. Data moves a lot. So data, somebody starts somewhere, and then someone copies it, and different use cases come up. It's copied even more and more. So the data lineage and how it's moving around in the cloud, and even detecting risk, and particularly point out how it came from, where it came from. I think that's very critical. And false positives. I touched upon this briefly. Security fatigue is common, definitely. When you launch it, you could have like thousands of risks, and often we get the feedback, okay, how do you narrow down? And one of the techniques I talked about is the metrics-based approach. It works very well, but there are even more ways in which we have to really, avoid, suppress false positives. So that's an area that can be very interesting to look at further. And finally, the piece about multi-cloud. When I started with, we have AWS, GCP, and so on, different cloud providers. What we see is that many businesses continue to use more than one, and there are a lot of reasons behind that. So DSPM solution, like when you build this, it has to work with definitely more than one provider, and it has to have a good solution for dealing with all this, and provide a very holistic solution for DSPM. That's important. Okay, I'm going to, this is my final slide. Final thoughts, right? So when we have grown a lot, and there was an area called cloud security posture management that's been well known. And looking at purely from data security and data protecting data point of view, DSPM is coming up really well, and a lot of interest. And it feels like it's a must-have rather than nice to have. And basically, I talked about, to really drive innovation and disruption, we need to keep the data secure and safe. And so it feels like more critical to solve this really well, and make this happen. So I think that's it. I'm going to stop here. Thank you. Go to Q&A.
Thank you. Really appreciate that. Certainly some challenges, some big challenges there, but real clear ideas on what we can do, which is impressive. So let's see if we have anything in the Q&A yet. I don't see anything yet, but I do have a question for you. And that has to do with kind of maintenance of this, of your data security posture. You've kind of gone through the steps required in order to understand what that is. But 6 months down the road, how much of this do you essentially have to start from scratch? And are there things that you can essentially say, yeah, we got that one right, and we don't need to redo it?
So actually, the current way we are doing this is continuous. I think that's a point. Maybe I didn't go into details, in the sense that for example, in our things, what we're doing is every one day, we are almost looking for all the changes that happened in the last one day, and just updating our graph to reflect all the changes. So let's say 12 a.m. every night, we're running this operations to update the ETL, and that basically makes our representation, the graph representation, as the current. And at that time, we are detecting all the risks and bubbling up. So in a way, it has to be a continuous operation, and it has to work continuously. So we can't. But the cycle between these two updates, and that's typically a day. It could be shorter, but that can be expensive to update. But it is continuous. So every day, this is the current state of the cloud, and this is the current state of the data security posture. I hope.
Well, thanks. Let's move on to the Q&A here. Rishi Gupta had a question. What do companies do once they have this graph built? Do you have examples of how this has
Okay, sorry, I'm not looking at the, okay, and now I got the right, what do companies do when they have graph built?
Yeah.
So in terms of what we are doing is we're projecting all the risks, right? There are like two aspects to this. One is that predetermined patterns that we are exposing will be exposed to them as a set of risks they need to take action against. So typically what, those, so there'll be a DevOps team and they look at it. Okay, this data store has sensitive data and it's exposed to, outside, or it can be exposed. So typically they adjust the security policy or even restrict the access more, right? They make it even much granular or very strict access. That's one. The second thing is many teams I've noticed, we have built like a visualization where they take this and look at it and then say, this is my whole layout of my cloud infrastructure. These pieces are not necessary, right? They actually poke into it and then say these pieces are not necessary, and they try to cut off all the links. Basically, excess privileges, excess permissions, and all the things. Now they have that view into it, and they can really change policies and deploy. And once that happens, when our next update, our graph gets adjusted, and they can really see impact of what they have done. I hope that answers the question.
Thanks.
Should I go through one by one?
Okay. Yeah. Go ahead. Unfortunately, I was like, I can't look at the
Questions.
Mute and unmute and look at the questions at the same time for some reason. So I'm getting a little delayed. So perhaps you can go on to the next.
Yeah, next question is from Donald Mold. So what type of data is most vulnerable in the cloud? I think what type of data? So many times what we are noticing is personally identifiable information, right? Like that's where people keep some type of invoice or financial data, and those things will look very common. But when you look at it, you might find credit card numbers and addresses, phone numbers, and so on. And that's what we see most common, in the sense that these are like almost all the companies have these business transactions, and it's not like exposed, more like they are sitting there and they may not really have a good security control over that. And if you once you expose certain risk, and they'll be able to apply and restrict access. Okay, a lot of questions. So I'll go through number one, and please feel free to update in the next one. So next one, do you do any relevant work with companies gaining access to your data and selling, like the Facebook scandal? If you, great question. So we have a concept of external access. Many companies that use a product have this notion of, can I get to know who all have access to my data from outside? And we can detect it, right? Like when I presented, I talked about the graph, and many times you see an access coming from not internally, from externally. And that relationship is actually part of our graph. And many, like we even have a very, some of the risk we expose, and companies can know this data is not only accessed by internally, but also externally. So absolutely, we do this, and customers are very interested in this aspect. I have experienced cybersecurity, but none in cloud. What would you recommend for cybersecurity professionals who want to get into cloud security, but don't know where to start? I think I would say you have to know at least some cloud providers and how they do things. For example, many certifications are available for AWS, GCP, Azure. You can always pick one that you really like. And so knowing that fundamentals, then you can expand to security, because a lot of security fundamentals will apply, but just you have to know some of this actual cloud, the providers, how they approach, what are the APIs available, how they're really doing this. Some certifications, just doing some basic certifications just will get you started, and just interact, merging the security background, cybersecurity background will work great. That's one. Okay, next question.
Yeah, actually, I'm going to jump just because we may get tight on time, but I'm going to jump ahead because there's one that a couple of people have asked that are variants of the same question. And so if this thing will let me pull up the Q&A again, we have a couple of people who've asked about the technical challenges, kind of the toughest technical challenges that came up with this, specifically in pulling metadata to populate the graph.
Yeah. So actually, it's a great question. This is a struggle with as we continue to have challenges. So two things, like one is the time lag, right? So there's a graph, we have data streaming in, we want to update. Many times updating takes time. And if you don't do throttling or if you don't do batch properly, you can really mess up some of these queries and update queries. They all fail and you're really not able to update the graph. And so in terms of understanding the graph, throughput and batching your queries is kind of one of the technical challenges we are even running into now. One example is, let's say today you're running update, you're just finding like, it's very much possible they just the deployment changed a lot of things. Then what happens if your update is instead of 100 on a typical day, it's like 10,000. Then you'll just start issuing all these update queries. It'll be a problem. So kind of knowing your throughput and having a way for you to throttle will, is one of the important ones. The second thing is, I talked about this, like when you do an update, can you do it cleverly so that you're not interacting with the whole graph, maybe part of the graph? So that goes to data model. Maybe those are the two kind of important challenges we have run into and still kind of open. Professor Clifton, should we move on to the next question?
Yeah, let's go ahead and move on to the next question.
Okay, so next one, what are some current emerging technologies, approaches for performing context matching for data classification? Actually, I really don't know precisely how it's going to look like. I think this is, again, I put it there because it's almost like a research area we've been discussing. And sorry, it looks like I don't have a good answer for that particular question. Maybe I'll find out and I can share. Mainly, maybe one insight I can give you is that the graph always has a really good idea about how the patterns are emerging. For example, you have users and groups. Users belong to certain groups, and these users are always creating sensitive data. Let's say if you know this information, can you start creating these relationships without even scanning, right? Without even doing all this expensive classification. And that's the only thing, that we think might help us, but probably there are plenty of ways the patterns can be recognized from the graph. It can be really used to tag all this, sensitive data. So I feel like it's more of pattern matching in the graph and bringing that information back into the graph. So it's an interesting problem, a very interesting problem. And if you have time, definitely just take a look at that.
We have a related question, which is a little more specific. Whoop, it just disappeared from my list, having to do with the context matching. So perhaps we want to go on to the next one on the list here. Working with companies or individuals, and do you have you worked with kind of individuals or smaller or startups, and what is the key difference in the kinds of data they?
Yeah. Again, a great question. So far, we are working with companies, and but our product, like anybody can use it, and so what's the key difference? So I think okay. So one thing is that companies, when they start using the product, when they classify what, they're often surprised. So what they find. So that's something that, finance data or PAI, they don't want to see it, but typically you might find it in their environment. Individuals can use the product, but I don't have a lot of experience like interacting with them. I think they're using the product, but I don't have a good feedback about what's the difference between the companies and individual. Sorry, that's all I have.
Here's an interesting, are data breaches, are, when you find them, do you find them that they're malicious or by accident?
Actually, in our use case so far, what we are focusing on is mostly by accident, right? Like it's a misconfiguration or done some time ago. Somebody forgot about turning it off, some access, and that's what we have so far come across. Nothing malicious, as far as I know. So, but I think the solution in terms of what we want to do is even catch the malicious ones. Yeah, somewhat mostly by accident, or it's not accident. Maybe third category I want to add is more about not knowing all the details of different clouds, right? So basically they don't know the setting exists and they don't set it, and basically makes it the exposure more likely. So
here's a couple of questions that I think go together, and I'm going to pose them to you that way. Because the first is, because I think the second question, your answer to the first may actually come into it. First question was, do you predict growth in the cybersecurity industry in the future? And what is a way to learn more about it if you don't have experience in computer programming or technology? And the second question I think is related to this is, what's the hardest part of when convincing a company to use Normalize?
Okay. First question is absolutely, growth. Actually we were, there's a, statistics. I don't know, like I know it, but feel free to check it out. There's a, the cybersecurity or security space is going to be a, $2 trillion market. And so going to be tremendous growth. The plot I showed you in terms of public cloud usage, it just keeps growing. And we are, like if you look at what we want to do, we always want to do new things. So, and that new things in a public cloud will always lead to a lot of these problems that are very unique. Data security posture is very recent, and it's completely, many companies are already working on it. So absolutely, it's going to grow. And if you don't have a background, right? Actually, you don't have to program and be part of cybersecurity. I think that's something that so that right. Even our company, right? Like we have risk detection, and for writing all these patterns that we want to find out, there's a position for it. People with analytics, like, or people who have background in writing queries, they apply for it, and they are great candidates. So absolutely, you don't have to be a programmer to be in cybersecurity. Go for it. The second one about what is the hardest part in convincing Normalize? Great question. When you do something innovative, companies are, they're scared, right? Like they have to know, because now we have a product kind of shows what are the weaknesses, right? Like what are the ways in which you can be exposed. And companies definitely have the trust factor to immediately join and do something. And so the establishing the trust is one of the hardest part. Definitely once they talk to us and once they know our background, and they're very heavily engaged, by the way. So you can always overcome that. But I think the initially, they're just exposing their infrastructure to us, and which we keep it very secure. But that's the hardest part. And again, I think it applies to all the security companies, like in the beginning, they don't want to even go out to public cloud. Now they're all going out to public cloud. And now people are installing agents from different companies to collect data, which is very common. So my hope is that this will happen. But again, my last slide is about, we do it right way, and it really helps our overall field, right? And it really helps with innovation. So it's important, and that's a small, that's something we need to overcome.
Well, thank you.
Oh, actually, there is
oh.
one more question. Do you guys mind if we ask it?
Oh, please do.
Sure. From Owen, he asks, can deep learning algorithms be used to track the movements of data? And if so, what are the problems with this approach?
Okay. I don't know much about deep learning, but maybe I'll talk about the problem that you can kind of see whether it can help, right? So the pattern matching, the data movement is harder because you need to do a lot of data matching, right? Data crunching. And if you go behind why data crunching is harder, because of time and cost, right? So do data crunching, you need to spend money, and it's going to take a long time. And so now, how do you solve it? You need to have a way for you to run this very efficiently and without spending a lot of cost. So if in case deep learning can help you to do that quickly and not spending too much cost, that can be absolutely a game changer, no problem. But the objective is important. The important, basically do it faster, not spend a lot of compute. So if you kind of see, and if it works out well with deep learning, absolutely, that can be useful.
Well, thank you, Amorthi. Very, very interesting things, and pointing out just how big our cybersecurity problems are, and widespread, and even understanding what our risks are and what our problems are is a challenging, both technical and management problem. And it's wonderful to see some of the kind of advances and technology you're developing for this. So I'd like to thank you. Thank you very much for this talk, and look forward to hearing from you again, in another few years.
Absolutely. Yeah, thank you very much for having me, and great questions. I cannot see all the audience, but absolutely, thank you. You've been a great audience, and hope to come back.
Thank you to both of you. We appreciate you being here and giving the talk. And then again, I want to remind you, if you want to come back, we have our symposium the end of March. It's live. So if you'd like to come and be in the audience and network and learn a little bit and share some of your stories and your research as well, that would be fantastic. So if you go to the website, you can find all the details, but it is March 28th and 29th that will be on Purdue's campus in Stewart Center. So thank you again, everyone.
Absolutely. Thank you.
Thank you.
Thank you.
Take care.
Bye.